Hi, my name is Vishnu V and I'm a student at Department of Electrical and Computer Engineering at University of Florida. My pattern recognition project is face recognition using convolutional neural networks. So facial recognition is of much importance in the field of security in the recent times. Be it maintaining the safety of a common household or identifying a sought-after criminal, facial recognition plays a vital role. And because of these reasons, it becomes essential to build a face recognition model that will recognize faces to the highest level of accuracy. There are a lot of commonly widely used methods to implement face recognition available. In this project, however, I have used convolutional neural networks to build a model that recognizes faces to a very accurate level. Although convolutional neural networks are used in a regular fashion in implementing face recognition models, they often come across large errors and losses. This occurs especially if the design function wasn't optimized. In this project, these losses are addressed, and I have put forward different methods to tackle and overcome them. The model developed was trained and tested using a sample dataset. When tested, an accuracy of over 98% was achieved. So the problem under face and the study is face recognition. By taking the basics of code available online, I was able to construct a convolutional neural network which was able to classify faces based on feature extraction. Although another famous approach taken for face recognition is k-nearest neighbors algorithm, the accuracy of this algorithm decreases severely when we are dealing with large databases and when the value of the parameter k increases. So in the figure, the basic steps of face recognition are given, which include capturing the image, which are then fed into whatever algorithm is classifying them. This algorithm performs the feature extraction, which is basically extracting the features on the face, which include and are not restricted to the alignments, angles, the eye lines, wrinkles, etc. And based on the extracted features, these are compared to find the similarity with the other images and are classified, which is done in the matching step. So a more detailed step-by-step of what is happening in the face recognition is what we have the images which are sampled and the dimensionality is reduced in order to reduce the computation, which are then fed into the convolutional neural network, which performs a set of convolution and mathematical operations and classifies the image. So for the face recognition, there were mainly 4 steps involved, which were detection, 3D alignment, feature extraction, and classification. Although usually for face recognition, datasets of 1,000 images are used, for simplicity, I have classified these images into 2 classes. The depth of the neural network, which are constituted by the hidden neuron layers, and the parameters involved define a convolutional neural network. Again, for training dataset, I used 30 images of each class, divided into training images and resized training images. The use of the resized training images is that after the convolutional neural network's training stops in the first phase, there might be some features present in the image that it failed to pick up. This is why we have this resized training images, which helps retrain the model. Both of these help the neural network identify the face. The architecture of the CNN, the convolutional neural network, involves the input layer, convolutional layer, pooling layer, fully connected layer, and the loss layer. Okay, so the input layer receives the input image in a certain format and it feeds it to the next layer, which is the convolutional layer. The convolutional layer of this convolutional neural network is what actually performs the convolutional operations through a set of mathematical operations. The outputs of these layers are fed to the pooling layer. The functionality of the pooling layer is that it helps reduce overfitting. This is a very important problem found in machine learning, where the model may try to fit itself to the trained data, and this can cause a large amount of error in the test data set. And the fully connected layer is the feed-forward neural network, which helps in giving the output and classifying the data images. So each layer in the CNN, like I said, has its own function and helps in identifying the data set. So apart from convolutional neural networks, there are some other existing methods, which are k-nearest neighbors algorithm and principal component analysis. First, I will talk about k-nearest neighbors algorithm. So when using k-nearest neighbors algorithm, one usually needs to enhance the image so that the features that are to be extracted stand out and can easily be identified. One such technique to enhance the image is called contrast stretching, where the contrast of the image is increased. This ensures that the intensity of the image meets the desired standards. After this is done, the characteristic features of the image are found using feature extraction. K-nearest neighbors algorithm is one of the simplest algorithms found for classifying datasets, but the accuracy of the classification is not high. The training samples and the testing samples are determined by the members. If the value of the parameter k is equal to 1, then the image is assigned to the single neighbor class that is the nearest. Since the entire algorithm depends on this one step of assigning the image to the correct class, the accuracy of classification is highly dependent on the initial set. However, the accuracy can range in a large scale, which makes this algorithm very unreliable, and when it comes to large and important data sets, this might not be used. So although k-nearest neighbor algorithm is very easy to implement, because of this problem, it is not widely used. Another one is one of the methods to implement face recognition is principal component analysis, or PCA. So in this method, the pictures have to be vectorized before they are given as input. The image is therefore converted into a two-dimensional matrix where each element of the matrix is the grayscale value of the pixel. After applying the principal component analysis algorithm, the vectors are reduced to what are called principal components. These principal components that are thus obtained have a certain set of rules, like the principal components obtained from the same matrix are orthogonal to each other. Then, using a series of mathematical operations, these vectors are projected onto eigenfaces, which are considered the most important pictures in the dataset. This eigenface is constant for the entire dataset. However, there's a vector called the weight vector, which varies through the entire dataset. The value of this weight vector is similar for images of the same individual, and hence helps us identify the individual. Although this is also PCA is also a very similar algorithm to k-nearest neighbors algorithm, the accuracy is slightly better than k-nearest neighbors algorithm, which is why it is also widely used for face recognition models. So for performance evaluation, I've used a test dataset which is available online to evaluate the convolutional neural networks model. An accuracy of over 98% was achieved. When tested with the k-nearest neighbors algorithm, however, it gave an accuracy of 79.8%, which is roughly approximately 20% less than the accuracy of CNN. Hence, the CNN, the convolutional neural networks model, gives a better result than the k-nearest neighbors algorithm. So here in the output, you can see two pictures. The rectangle or the square which is found, the blue rectangle which is found, helps identify the face. So the convolutional neural networks has correctly identified the face using the features of the image. And using the feature extraction method, it is able to classify it, and the name provided above the square is what it is classified into as, and hence the accuracy which is found is 98%. So in this project, I was able to effectively implement face recognition using convolutional neural networks. An accuracy of over 98% was achieved in the test dataset. Libraries like PyTorch and OpenCV was useful in extracting the deep facial features, processing them, optimizing the loss function, implementing the distance function, and classifying them to effectively recognize the face in real time or in databases. Throughout this project, I was able to learn a lot, including how much information is being carried through a single image and how face recognition technology really helps in tackling the security issues, be it to unlock a simple smartphone or to recognize people in security cameras. I learned how to extract the features from the image and use it to train a model. While working on the code in Python, I was able to learn a lot about the different functions offered by the libraries like PyTorch and OpenCV. This was extremely useful in performing various tasks, including image transformation and training and testing the model. These are the references that I've used. So now I will be talking about the code that I've used to implement the face recognition model using Haar cascade algorithm and convolutional neural networks. So here I first imported the libraries and I will run the code first. So the first time I run the code, the neural network is trained according to the training images and the resized training images, which helps improve the neural network to get more features from the image. So first I'm using OpenCV library to read the image, and then using the face detection function which implements convolutional neural networks, it is stored in a face detected array. After that, so the training images are gone into the faces array, and then they are put into the training classifier, which is basically the neural network code. And then this has to be executed only the first time it is run. And in subsequent runs, we already have the model with us, which has already been trained. So we just have to do these two steps for the subsequent steps, which will hugely reduce the training time because it is already trained. Now so for this example, I have two classes. First one is just Priyanka, and the second one is Kangana. Let's see if it has recognized it correctly. And when we go down, see, so this is Kangana, the class Kangana, and the rectangle has been correctly placed over the face, which means that it has recognized a face from the background, and also it has classified it correctly because this is a photo of Kangana. And coming back to the rest of the code, we have a for loop where the face is detected from the rest of the background, and there's a term called confidence, parameter called confidence, which is very significant because if we are not trained the model properly, then the confidence value would be less than 37, which is the threshold value. And if at all the confidence is less than threshold value, which is 37 in this case, then it won't be classified at all. This is because this convolutional neural network model classifies the image into two classes with a certain probability, and this probability might be similar for both the classes in some cases, in which case the neural network is not able to make a clear-cut definition of which class this image belongs to. In this case, it is not classified at all. And using other OpenCV functions, we have used to show the image in the output. And also, for this, there's a weights which are used for the convolutional neural network. There is an NPI file which I will be submitting, which is what is the trained in the neural network. And for the database, this is what I've used. These are four sets of images which I've used. And also, for an example, it is able to recognize multiple faces in the same image. This is a photo where 6 faces are present, and all 6 faces are recognized properly. Thank you.